Going to be problem number 10 from section 4.1, and the problem is f of x is equal to 3x squared minus 5x minus 2, and that's all divided by x squared minus 9. And the first thing we're asked to do is to find the domain. So to find the domain for a rational function, we need to look at the denominator. So the domain is going to be all real numbers, negative infinity to infinity, except where x squared minus 9 is equal to 0. So we need to figure out where is x squared minus 9 equal to 0. To do that, we're going to factor. So this is the difference of two squares. So that means that my factors are going to be x plus 3 and x minus 3. Setting each of these equal to 0, I end up with x is equal to negative 3 or x is equal to 3. So my domain then is going to be all real numbers except x equal to negative 3 and x equal to 3. So to write that in interval notation, it might be helpful for you to make a little graph, number line, so that you understand you're going to include all numbers except negative 3 and 3. So to write that in interval notation, it's going to be from negative infinity to negative 3, in union with negative 3 to 3, in union with 3 to positive infinity. Not inclusive. The second part says to identify any vertical asymptotes of the graph of y is equal to f of x. So we're looking for asymptotes, and then the third thing is to look for holes. So we're going to look for asymptotes and holes. We're going to do that at the same time. To do that, we're going to factor our numerator. So besides factoring the denominator, now we're going to factor the numerator. So factor the numerator. And this one's a little bit tougher to factor, but when you do factor it, you're going to find that you have 3x plus 1 and x minus 2 are your factors. And then remember that this is my denominator, x plus 3 and x minus 3. So we're going to look at our asymptotes first, and I'm going to have an asymptote wherever I have zeros in my denominator. So asymptotes, and these are vertical asymptotes, so I'll put down vertical, and we're going to call that VA, are going to be where x plus 3 is equal to 0 and where x minus 3 is equal to 0. So my vertical asymptotes are going to be at x equal to negative 3 and x equal to 3. And remember, they're invisible vertical lines, so they should have the equation of a vertical line. Equation of a vertical line. Now, if I would have had like factors in my numerator and my denominator, so that I could have canceled something out here, then instead of having a vertical asymptote at these places, I would have had a hole. So if you have common factors in the numerator and denominator, holes appear when there are like factors in the numerator and denominator. Since we don't have any like factors on this particular function, there are no holes. So let me write that down. This function has no holes. The next thing we need to find is the horizontal asymptote, if there is one that exists. So to look for the horizontal asymptote, I'm going to go back to my original function. So we're going to find horizontal asymptote. So I'm going to go back to my original function, which was 3x squared minus 5x minus 2 divided by x squared minus 9. And we have three different options for looking for our horizontal asymptote. The first option says that if I have the same power in the numerator and the denominator, so I have a second degree polynomial in the numerator and a second degree polynomial in the denominator, then my horizontal asymptote will be the coefficient of my x squared term in both the numerator and denominator. So my horizontal asymptote is going to be in the form of a horizontal line, y equals, and then I have 3 in the numerator, and remember, I have a 1 in front of my variable in the denominator. So my horizontal asymptote is going to be 3 divided by 1, which is 3. And again, this has got to be in the equation of a horizontal line. Okay, the next thing it says is to find the slant asymptote. Well, if I have a horizontal asymptote, so if there's a horizontal, then there's no slant asymptote. For there to be a slant asymptote, you would have to have the degree in the numerator be one more than the degree in the denominator. So the numerator would have to be 1 degree more for there to be a slant asymptote. And then the last thing it says is that we need to graph the function using a graphing utility and describe the behavior near the asymptotes. So here we have the graph of the function, and we're going to be asked what happens when x is going to a very negative spot on the graph. So we're looking what happens when we go to the far left on the graph. As x gets to negative infinity, my graph is approaching my horizontal asymptote, which is y is equal to 3. What I'm going to do is I'm going to go ahead and graph my horizontal asymptote. I've got my vertical ones in here. I'm going to go ahead and graph my horizontal ones so I can see what's happening with my graph. So I'm going to go into here, and I'm just going to put in y is equal to 3, because that's the equation of my horizontal asymptote. And so what's happening as I go farther to the negative range here is that my graph is going to approach 3, and it's going to approach 3 from the upper part of it, which means it's going to approach 3 from the positive side of my function. Next thing I'm going to look at is what happens as the graph comes up to my first asymptote, which is negative 3. So what happens as x approaches negative 3, and we're going to be approaching it from the negative side of the vertical asymptote. And what happens? My function is going to go to positive infinity. It's getting very, very big. What happens as x approaches negative 3 from the other side, from the positive side? What's happening to my function here? It's going very negative. So f of x is going to negative infinity. Then the next thing I'm going to look at, what happens as x approaches my next asymptote, which is 3, and we're going to be approaching it from the negative side. What's happening to my function? So f of x is going to negative infinity. What happens to my function as I approach it from the right side, which is my positive side of x? It's going to go to positive infinity. And then what happens to my function as it gets very, 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 very far out onto the right side? So what happens as x goes to infinity? And this is really interesting. You might want to use your trace feature on your calculator, and you want to bring it over to here. Right now we're at x is equal to 0, and we want to be over to the right of x is equal to 3. So around maybe x is equal to 4. Let's just see what's happening to our y values. So right now we're here on our calculator. I want to see what happens right around in here. Keep an eye on the y values of the calculator, see what's happening to it. We're coming down, we're getting closer to 3 at 3.4, so we're real close to my horizontal asymptote. 3.2, 3.1, 3.03. Now look what happened. We're actually below our horizontal asymptote. So what's happened is we have crossed the horizontal asymptote. As we continue x to the right, we're now at 2.91. We're still below the horizontal asymptote. So keep a look on that. See how we're going down even farther. We're below the horizontal asymptote. Okay, you may not be able to see this right now, but right now we're going back up towards 3. My numbers are increasing a little bit at a time here, and I'm coming back up to 3. So let's see if we can get it way out here. So can you see where I'm back up to 2.8 now? So what we're doing is we've come down, we cross the horizontal asymptote, and now we're coming back up and approaching it. So we're going to be approaching 3 again, but we're going to be approaching it now from the underside instead of the upper part. And that's how our graph is going to look.